This is the Okeanos Explorer. We are about to encounter the seafloor on dive 03. We are back at the Biloxi Salt Dome. This is Site A, a site we visited on dive 1. We have modified the Little Herc ROV to collect gas with a clear plastic cylinder at the front of the vehicle. We will be spending the dive working on techniques to approach the seep, estimate bubble size and rate, and then we will attempt to collect gas in this cylinder. We are not sure, but we think that that gas may form hydrate. When it enters the cylinder, we will collect approximately 10% of the cylinder's volume with gas and or hydrate, and then we will rise at a regular rate, probably something on the order of 10 meters a minute, to watch expansion of the gas or exsolution of the hydrate in an attempt to estimate the volume that we have collected in a specified period of time at the seep. If we have time, we will do this process twice. We will go to the seep, collect gas, rise to around 300 meters, watch escape of the gas, and then repeat. So stay tuned and watch us try this. This hasn't been done before. We are now seeing the seafloor with Little Herc. From the pilot cam now is very different than what we're used to, because we are having to view with shadows related to the frame and the cylinder that are now affixed on the forward part of Little Herc. So we'll all have to get used to the modified view that we're getting as a result.
Right now the camera is panned downward, right?
Correct.
Because straight ahead would be the cylinder.
That's correct. And I don't know yet, Dave, is the bucket closed now? Did we close it as soon as we got into the water?
Bucket is open.
Bucket is open. But we will, before we get up and over the gas streams that we will encounter here, we hope shortly, close the top of the cylinder, and the only way that we can do that is in fact pan the camera further down, because the handle on the camera is the way we close the cylinder. Yeah, the Sirius view now shows a good view from above Little Herc, showing the relationship of the new equipment on Little Herc to the primary ROV frame in front, cylinder oriented vertically. There is a spring-loaded cap. That black cap that you see is designed to be opened and closed. We can close it and open it using the camera tilt, the primary camera tilt on Little Herc, and we will do that before we situate the ROV over bubble streams once we encounter Seep 2. The water is extraordinarily clear today. Yeah, we're seeing some topography right in front of us now. Some scattered. Yeah, I think you're very close now. Yeah, I believe that's where we are. I believe this is it. We are not seeing bubbles yet. As I have explained before, our visibility is a little compromised because you can see the bell-shaped bottom of our collection cylinder at the top of the Little Herc view, and shadows from the cylinder caused by the flanking lights on Little Herc compromises our visibility a little bit, but shouldn't be too much for identifying the location of our gas escape. These bubbles were pretty small. There were at least 2 discrete streams, but we don't know what the time variance on these streams are. Could be less 2 days later. We simply don't know. We're on the seafloor here. This is dive 3. We have Little Herc is quite near or at the location of what we have designated as Seep 2 during dive 1. in this area. We're now investigating a ridge here with some scattered carbonate hard grounds. We have not as yet seen any bubble escape to confirm that this is in fact seep 2, but we're giving it a close look. There is a lot of bacterial staining and so on, which we have associated in the past with proximity of gas. And we're not, but our, as I have said, our visibility is a bit compromised by the presence of the gas collection device in front of us and shadows created by that device and the frame holding it. Gives us a little bit more. What we're going to want to do, guys, is scan along the ridge from one end to the other. We're looking at one edge now. But the outer edge is what I'm talking about, the edge that, the steeper edge, the edge to the right. Going to want to get close and look along it. I think we're going to see that if we do see gas, it's going to be in proximity to those outcropping hard rocks, or what we've been calling carbonate hard grounds. So we're going to want to zoom in close to the lips of these features, these overhanging lips where the crabs are hanging out. Take a pretty close look at all of those. It's actually where the shadow is that we're going to have, that I'm actually most interested in, where the whiter staining gets darker. So we'll have to play the game of moving the vehicle a little bit to scan the areas that are interesting. Yeah, that's the idea, gentlemen. That's what I'm trying to do. We want to do a pretty close terrain scan all along the outer edge of this ridge.
Hey, Jamie, on the right-hand side of the screen in the center, we see bubbles coming up.
To
the
right
of the crab, the second mouse.
We're headed there. We're headed there now.
That's the same spot as last time. I'm looking at an image of it right now. See, Jamie, there's this little patch of white stuff there. There's this rock and a little rock there.
Yeah, the crab hasn't even moved. That's right.
Yeah, we're looking at video of dive 1 and that spot in the center of your view right now with some bacterial staining down low, off, and then above. That was the area we were looking at bubbles the other day.
That's it. Yeah. Guy.
Yeah, I know. It's the, see, look, it's the exact same one, I think. This is where they were before. Like, on either side of that little rock.
It looks like the same crabs even.
Yeah, once we get set up,
navigating back to this.
yeah, we're going to have to make an assessment about whether it's more stable for you to set down or float. But before you set down, we're going to want to zoom in and do some time series measurements of bubble streams and if possible, estimate sizes.
Yeah, lasers when you get a chance.
Yeah. May we have the lasers when you get a chance, gentlemen.
Thanks, Jamie.
Now remember, Tom, when we zoom in tight, it's going to be harder to, or impossible to see those lasers.
Yeah, I've got the video from, you guys posted the video from 2 days ago, and so I've got a rough idea of a dimension on that piece of rock where they're coming out. So
okay.
I think we'll be okay. That's like 10 centimeters. I think that's about 10 centimeters right there. That's right there.
said some of the bubbles are going into the cylinder? Oh, yeah, I wouldn't think so.
Cylinder's still open. Hey, Jamie, is the cylinder open or closed?
I guess I'd like to use the zoom capability as much as possible. At least what we don't want is for gas to get into the cylinder before we would like it in. So let's find out what our limits are with video first. We're going to want to try to center the lasers on the streams if you can.
It's just the multiple angles of the light. So it's two bubble sources, but it's not looking quite like it looked the other day. It's like hydrate on the underside of the right here. Certainly the source.
Now, for everyone watching, those lasers are 10 centimeters apart. What we're trying to do here is to spend a little time seeing without getting up and over the seep, because we don't want to collect gas before we're ready. We want to estimate rates of release of the bubbles using our video and using our zoom capability, and estimate bubble sizes. We have at least 2 and perhaps more discrete escape streams in front of us, and so this is all part of the prep work we're doing before we actually try to collect gas.
Record log. What were this is overlaid on the video? That's slow. So one thing we'll want to do is get an idea about the rate, like 2 bubbles. Each bubble stream maybe once every 2 seconds, but slower.
Can you confirm for me, gentlemen, whether that cylinder is now closed or open? Great.
It's open, they said.
What's the answer, Jamie?
Open.
Open. Thank you.
And right now we're trying to not get very close so that the bubbles go in the cylinder. So we're using the zoom as much as possible.
Right.
Again, gentlemen, if we can position the vehicle as, and I know this is always a bit difficult, but we'd like to straddle the streams with the lasers.
This is a really great start, guys.
Video, can we get zoom on the Sirius camera of the front of Little Herc? That's great. Yeah, we'd like to try to keep. That's a good view of the cylinder that we can't get when Little Herc is up close to the seep.
She's allergic to bubbles.
Yeah, it looks.
You see the hydrate on the edge of there, Jamie?
Yes, yeah. We've seen that, Larry, before. It looks to me like there is hydrate coating. It suggests to me that we will be forming hydrate when this gas gets into the cylinder. I see at least 2 locations for bubbles. There may be a third.
The bubble source. Nice shot of the bubble source right there. Yeah. Right in the center of the, you see the bubbles coming out there? Right.
I think it kind of seems like 3, although
That's
the
excellent.
one on the but the one on the left is.
That's excellent, gentlemen. That's what we wanted
2
to do.
areas it seems like 2 locations that are very close to each other, if I'm not mistaken. Yeah.
Yeah, there's one on the left edge of the hydrate, the little overhang, and one on the right.
Yeah,
Yeah, 2 very discrete locations.
Yeah, certainly 2 discrete locations. It's possible that gas is ponding under the overhang and then coming out in two different, might be one source of gas just coming out as two streams.
It looked like they're about 10, 12 centimeters apart.
Yeah, I think so.
That's great. Right on there.
Yeah, that nice shot.
Oh, that's good. Cool.
Yeah, Tom and Larry, I'm at your pleasure here. Let's make sure that we give you enough video to give you statistics on rates and size, but you need to let us know what you would like.
Okay.
Okay, this is just wonderful right now.
It looks like combined, the two sources look pretty similar to me as far as bubble size goes, from what I can see here. And in aggregate, it looks like we're getting one bubble every 1 to 2 seconds. What would be great to have is, what I was estimating bubble size, I would grab a still and basically count pixels and compare it to the lasers. I don't know if forever. That is a great shot right there.
Yeah. When you hit the hydrate with the laser, you get the scattering that's spectacular.
So what we'd like is just a rough estimate of what that size is. My guess is it's going to be on the order of 2 to 3 millimeters.
Yeah, they look to me, although my memory can be faulty, as though they are bigger generally than they were the other day.
I was guessing this was on the order. So 2 days ago, we had two bubble streams. We had one that to me looked like it was this size, and it was coming at this kind of slow rate. And then the small stream was maybe half as big, but coming at a rate that was 2 or 3 times greater.
Right. Yeah, the subtle characteristics of these streams look a little different. They look as though they're timed a little more closely in terms of rate, and the bubble size differential doesn't look as great. But, you know, if I had to guess, it looks as though there is more gas coming out from this vent today than 2 days ago.
I think you're right, particularly because those small bubbles, even though they're coming at a faster rate, don't have a lot of volume associated with them.
Right.
So I would agree, Jamie.
What's so good is that you see clearly where the source of the bubble is. And so when you get the bubble size, you'll know where it is relative to where the lasers are.
And they sometimes come out in little bursts, like what just happened right there.
4 or 5 together.
Yeah.
I think the good news for us is that I think given the diameter of the cylinder, we can probably position the cylinder over both.
Yeah, I think that's
The diameter of our cylinder is 15 centimeters, and it looks as though those streams are about 10 centimeters apart.
I'm going to count bubbles. 3, 4, 5, 6, 7.
That's an excellent job, though, gentlemen. That's
Oh, man. 14. I'm tearing up.
and Sirius, if we can figure out a way to keep Sirius at an angle to Little Herc that allows us to see the front of the vehicle better, that would be great. Again, I defer to your ability to do this, but right now we're right behind Herc. The view we had earlier of Herc being quartered was better for visibility. Getting a very nice view in the Little Herc view now of bubbles rising into the water column in discrete streams. Looks like 2 discrete streams well above the seep. It's perhaps one of the better views we've had thus far of bubbles in the water column. Oh, that's excellent, excellent. That's an excellent view. That's the idea. So that would allow us, once we actually try to collect here, to actually watch the process in action.
So Jamie, by my estimation, if that's if those are 3 millimeter bubbles in radius, not in diameter, but radius, we're looking at a couple hours to fill that cylinder a quarter of the way full. That'd be a quarter of the way full at 300 meter water depth. If they're
Right.
5 millimeters in radius, we're looking at half an hour. That's a long time holding steady. I don't know if that's even possible.
So what Dave had suggested is that possibly, since this thing slopes upwards, is that if they go around to the right side, maybe they could get one skid down, perhaps, and stabilize a little bit. But we'll have to see how that goes.
That'd be super.
I think I'm seeing 3 discrete streams now. One to the right and 2 close together on the left. One from under the lip and one from a hole in front of the lip.
Yep, I think you're right.
You had to change the angle to confirm it, but I'm seeing 3 discrete escapes now.
Still within catchable.
They're all.
I think so. I think we're still within approximate 10 to 12 centimeters. Of course, it's still dependent on stability of the vehicle over a period of time, and if we're having to look at a half an hour or longer, I think Aaron's right. I think we may have to consider actually setting the vehicle down, but I don't know that I want to do that first. I might want to try to keep the vehicle steady in the water column first, and then if that is unsuccessful, try sitting the vehicle down. I don't know what that's going to do in terms of perturbing the environment.
Right.
It'll certainly reduce clarity of the water for a while, but I don't know what it might do to the seep itself.
Yeah, certainly.
I agree.
And one thing we'll want to do is when they have the bucket open, you want to really be careful of being keep track of that. Just keep counting bubbles that are missing.
Yeah. I think this view might get that very well.
Exactly.
So what can be troublesome when moving Sirius to the side of Little Herc instead of kind of being behind it is that it's possible that Sirius could pull on the back of Little Herc and pull it around. So this is kind of experimental.
Again, some really nice camera work. Hey, Jamie, when you get a chance, what's roughly the diameter of the base of the funnel?
15 point, wait a minute. Wait one. The diameter of the cylinder is 15.2 centimeters, but we've got a flared lower edge.
Right. That's the diameter I was wondering about. That's our capture zone, right?
Right. I don't know what the width of the flare is, but it's at least another few centimeters.
I've got a picture here somewhere. Let me look.
The picture should be on the front of the dive form for today.
Right. Oh, here it is. It's taped right to the monitor. Yeah. It looks like maybe it's 20 to 25 centimeters in diameter at the base.
Right. Right.
Tom, you estimate that the base is about 20 to...
For looking at bubble size too with these lasers right there.
Based on the photo, you estimate that it's about 20 to 25 centimeters, the base of that flare?
Yep.
Oh, okay.
Yeah, I'm looking at the drawing, Dave's drawing of the little herc
Okay,
and guessing.
right.
Look at that bubble forming. Beautiful. I think the way they're zoomed, they probably can't.
We know the size, I mean, we know the size of that.
Oh, that hydrate formation. We saw that earlier.
You know, that size. From many. Every measure, every picture of that.
Every bubble is another one.
Is measurable.
Yep. Absolutely.
Boy, it would be great. 4 plus. Sounds great. Look at this, look at this, look at this. Oh, oh man. Oh.
So every once in a while,
That comes
I thought it came from here. Might even be a fourth location. It's definitely not just an isolated spot.
yeah, so it looks like looks like the bubble size is being constrained by the whole path. I think from the bigger path we get bigger burps. See another thing. Yeah. Two, so I saw something.
Okay, Tom, Larry, are you there?
Yes.
Yeah, I think the wisdom here from Dave and company is that it's going to, given the amount of time we may need to fill the cylinder to the degree that we want to fill it, I think the view is that is going to be difficult with Little Herc in hover mode, that we're going to be better off trying to nudge her into the slope or literally at the base of that hard ground, with the risk, of course, being that we actually perturb the system we're trying to measure. But given the fact that it might be a half hour or longer for us to do what we want to do, the view is that that's the way to do it.
Okay, I think we certainly defer to that wisdom.
Okay, well, we're still getting the ship stable. We want to give every one of you of Little Herc doing this from Sirius. So we're doing a ship move right now to try to get the tether arrangement stable, with Sirius poised to the side and above as you see it now, so that we can use the video zoom capability on Sirius to give you a view of the process. When it's done, we'll consider our next move here.
Okay. Wow.
So Jamie, I see you've got, and I'm looking at the quad display, we're looking at the top of the cylinder, which is a great view because we can see if bubbles are escaping up through and missing the cylinder. As we do the collection, will the video pan up so we can see what's going on in the cylinder? Is that the basic idea?
Yeah, the problem we've got is that we don't have a pan capability on that camera. So that's why we're trying to do some work with Sirius to try to give you a view. I'm hoping, in fact, that we don't end up completely over the camera. I mean, over the cylinder when we start to collect. I actually liked the view earlier that we were off a little bit to the side, and we'll work on that to see what the optimal angle is between Sirius and Little Herc. It's obviously related to the tether and so on, but we made a ship move to make it a little bit easier for that to happen. So you can help us decide what's best for you. Okay, I'm corrected here. We will, once we get the cylinder over the gas, we will be looking at the tube from Little Herc.
Perfect. I don't think I phrased it well, but that was my question actually.
Right.
So thank you.
The idea is to give you a macro view from Sirius and the close-up view from Little Herc. There would be situations where that would be difficult, but the water clarity is excellent today, and we don't seem to have much current down here.
Yeah, it was nice of you guys to arrange that for us.
I worked on it all night.
Have a second cup of coffee.
And I've got pull. Larry knows this. So. This is a perfect day to do this. I mean, a perfect bottom condition to do it. There doesn't appear to be much current, and the clarity of the water this morning is really excellent. You're getting very good visibility of the bubble streams escaping.
Is the current plan to sit down or put an edge down in order to stabilize?
I think the votes are coming in, but I think the view is that is probably the better way to go, given the rate of escape of the bubbles and the amount of time we may need to sit the cylinder over this seep to collect what we want to collect. Might be 30 minutes or longer. The idea would be yes.
Well, let's hope that this lack of current doesn't work to our disadvantage when we stir a bunch of sediment into the water. But
well, you know, if we just nudge a forward skid and below the hard ground, we might get lucky and not do too much. I'm more worried about disturbing the plumbing.
Right, because that's very possible. I mean,
yeah.
It's just really conduits through sediment here.
And ice, which is extraordinarily fragile.
Yes.
So you could break a glass in order to study the glass, and you know, it's not as easy to pick up the pieces of the glass once you've broken it and study it. So I think I'm convinced that the two streams to the left are one in front of the other, pretty close together. The diameter of the three streams is about the width of the lasers. I think we are probably good to go with all three. You know, you shoot for the moon, gentlemen, and then if you get less. If you're stable in your configuration, the only thing I'm interested in ultimately is whether we can get a more oblique look at the cylinder using the Sirius camera. Right now we've got a bit of tether obstruction of the cylinder. I don't want to do anything, obviously, that puts you in positional risk, but I liked the view earlier where Sirius was a bit lower and more oblique to the cylinder. Chris, I think with our video zoom capability, you can actually keep Sirius a fair distance away. The idea is not to get on top of Little Herc, but in terms of space, but to get a more oblique view. So however you can do that safely is what I'm after. Roger that. That's just excellent video now of those bubbles escaping. That's probably the best view of bubble escape that we've had since we've come out here. Conditions today, water column conditions are just superb for this. Yeah, it's really good. Yeah, that's the idea, gentlemen. That was the angle I was after. Yeah, that was the angle I was after. Absolutely what I want. Yeah, that's perfect. So if we could maintain some that general angle and that general view, we can zoom in and out as Herc moves into the target and as we start to collect. Yeah, that's perfect. So if we could maintain some that general angle and that general view, we can zoom in and out as Herc moves into the target and as we start to collect. Yeah, the only downside is that the portion of the tube that we're going to be collecting in, the upper 10, 15%, is obscured by the frame, but you can't have everything. It's still, it's going to give us a pretty good spatial reference for bubbles entering the tube, which is good. We'll get two. Roger that.
Yeah, video, so we'll have a perfect view from the ROV camera.
And when that's set up, gentlemen, when you're comfortable with that, I'm good to go. I think the conventional wisdom here, it's not conventional, it's extraordinary wisdom, is that that we're probably going to want to touch the seafloor in front of the seep for collection. So looks to me like we're going to have to move Herc to the left, but when you're ready, we can start that process. Yep. Oh, can he? Okay. 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 We do.
Beginning bubble capture attempt. We're trying to get all three streams in there. Backing up right now a little bit. Holding there.
I am seeing bubbles entering the tube.
Is the tube, is it closed now, the valve right now, or open? Still open.
I think the idea is not to close it until we're sure we've got it centered and hoping that we're not immediately forming ice that creates a problem for closing it. Yes, give me a time for closure of the cylinder.
Ready.
Okay, I've started a stopwatch here, Tom and Larry. And we
Still open?
Closed.
we just closed it.
That's a beautiful, look at this view.
We are now capturing gas.
Oh, man. I'm not seeing any bubbles getting by. Okay, we can keep track of that and actually want to count to see bubbles going by.
Is there a crab in the tube? Oh, he's on the rock behind it. Never mind. Let him in.
Oh, there are bubbles going in. Oh, yeah.
Video is only seeing one bubble. One bubble at a time, you mean?
I think we're clearly over all three streams. I don't think that's a...
Oh, yeah, I think the funnel is much larger than the
Right.
diameter.
Yeah, it's what did we hear? 10 centimeters larger overall. So I think we've got the right kind of seep to capture all of what's there.
Hello?
Hello?
Yeah, this is Bill Shedd.
Hi, Bill.
Hi, Bill.
Good timing.
Hey, I can't see any of the video. It's not turning on for some reason.
And you're watching the
You
video
know
on
if it's operational?
the streaming from the web?
Nautilus website? Yeah.
Yeah, the video is not operating. Yellow on bottom.
Bill,
Yeah,
do you have a
we're
suggestion
collecting
track
gas
for
at
the
seep
Nautilus
2
live?
at dive
Kelly
site
said you
A.
need to go to the Nautilus live site.
Okay, the Nautilus dive site?
And
Not Nautilus,
I think that,
Okeanos.
oh,
Nautilus
right, sorry,
live?
Okeanos. I think that was Kelly maybe making a Freudian slip or
Yeah.
something there. But she said that she would
I'm
send
sorry,
you the link, I think.
Let me get a piece of paper and write it all down.
Kelly Elliott's going to send you an email, Bill.
Tell her to send it home. Because our Citrix web application is down. And I've gone around
Okay,
trying to
I'm sorry. She
find
sent
the
it to you
email I sent home.
on the event log. Are you on that?
What's that?
Are you on the event log?
I'm at the Okeanos Explorer site that shows the three,
It's Bill.
has the three screens, one of the navigation, one from above,
Bill
and the ROV itself.
All right, so you're not.
Is that the one you're recommending?
Hi, Bill. Just tune into the event log, and all of the links that you need are going to be posted right there.
Okay. Let me try again.
And it is nautiluslive.org. It was not a Freudian slip.
Yeah, you're right.
Well, it's coming out of the GSO.
Nautiluslive.org.
It's coming out of the GSO sites.
Okay.
We don't have no Freudians up here.
Freud is nowhere in the room.
Okay.
Or I can tell it to you.
So, Jamie, they're hovering there right now. They're just holding position in the middle of the water. That's incredible.
No,
That's correct.
Is that true, or are we set down a little bit?
No, we're off the water. We're not set down.
Huh. Okay.
Look at this. Oh, talk about a way to make bubbles, too.
Yeah, I think they've got the bucket nudged up against the side of the hard ground.
We'll get them to.
Okay, so all right.
Oh,
So the front of that frame is.
as you said, doing the grid. Yeah, this is like Tom said yesterday. He's actually taking care of the grid experiment and the volume experiment all
Right, right. So, you know, the cylinder, because of the graduated divisions in it, is actually giving us a census of bubble diameters as well. So, good enough.
One of the things we'll ask you to do is measure the distance in those, those 10% volume lines.
Can we pan a bit to towards the top of the cylinder? Is that doable, or are we at maximum?
No, seriously.
Right. Fair enough. I'm just checking. No worries.
1,400 meters diameter, that rope.
So if you were to pan all the way up, it would open the valve again. So. Oh, you got it. Okay, you are all the way up.
But it's, you know, it's a camera that's used to looking straight ahead, not a camera that's used to looking up.
Yeah, straight ahead or down is usually what you're looking at, of course, on the seafloor.
Exactly.
Look at it, you see it just sticking on top. We can't tell if that's hydrate running on top there or not, but you see the bubbles just come up there and stick to it. It's really kind of...
We've done this before, and we do get hydrate forming at top of the chamber very, very often, very rapidly.
Right, we think we probably are getting hydrate forming up there. We just can't pan all the way to the top because the camera doesn't go up. Well, so you can see now in the view now that the cylinder is kind of right on top of the rocker. It's nudged up against it anyway. Maybe that's helping to stabilize this a bit.
I guess if the stalactite reaches the bottom of the cylinder, it's go.
But it is moving, huh?
I know. I'm saying 5 to 7, but I just think we have to go a couple hundred meters above.
Yeah? Oh, dive super, sorry. Not.
Go ahead, Roland. Go ahead, Roland.
Jamie?
Okay, go ahead.
Jamie, you out there?
I think that was just the pressures on the bottom. Right, right there. But you could, when they were zoomed out, you could see it going really up just a little bit.
Seriously. They zoom on the camera.
Smooth it out.
What is that?
Well, that could be because we were hovering over it before, right?
You can see the hydrate forming just to the right of the left-hand piece of tape. See it up there?
Remember Aaron, huh?
Yeah, you never sent him that picture.
Yeah.
Yes, yeah, right.
See it?
So as Dave was observing that we could see some of the hydrate forming Just to the right of that left-hand piece of tape with the graduated, or the ruler basically on it.
Good.
Bill, are you able to see the video now?
Yes. Oh, yeah, yeah. I've been watching. Yeah, it's incredibly stable.
Right.
Very little current. You can see the snow is just drifting
Right.
aimlessly. It was so loud, I didn't realize you could hear me. Probably hear them a lot better.
Can anybody tell what shape that hydrate is taking? Is it kind of forming a cone in that one spot?
Looks like a stalactite.
Shape the hydrate.
Like a stalactite?
Kind of forming a cone in that one spot.
Yeah, it seems like all of the
can't-
bubbles, even though there are 3 streams, they all seem to be hitting the same spot. To me, I don't know. Maybe because I can only see that one part.
We're getting a long delay echo
Bubbles,
here.
even though there are 3 streams, they all seem to be hitting the same spot. Maybe because
Right. Jamie was just commenting on how photogenic this funnel is, and there's another bubble that came up kind of on the right. Jamie was just commenting on how photogenic this funnel is, and there's another bubble that came up kind of on the right. Well, see, squat lobsters don't eat methane hydrates, is the thing. They eat, you know, bacteria or detritus or whatever. Luckily, there doesn't seem to be a lot of mobile animals around. It's not like this place is covered with squat lobsters, because those are the ones that I would fear the most, because they just kind of, you scare them and they just shoot off swimming with their tail backwards into nowhere. They're not watching where they're going.
Hey, Tom, I'm seeing a little bit of movement on the funnel there. Yeah, I'd rather keep a wider look to make sure that we see in advance if we have a problem with moving. So coming in too tight is probably not as advantageous as this view right here.
So right now we're keeping a wider view just to see if there's any movement at all. We just want to be able to see it as soon as possible so we can correct for it.
I think we can move pilot cam underneath the bar and get that view. We don't need to see the top of the valve, because when I was noticing when the gas comes out, it just comes out through the holes on the sides. And we could probably get a bit more straight on view. Right now we're going to have a hard time gauging how much we really have in there because we're looking at an angle. Still pretty good though. Go ahead, Tom.
I don't think that. I don't think that's driving it.
I don't think that would be. I don't think it matters where the hydrate collects, even though in a perfect world we'd like to see it collect all evenly. It's not going to happen, and I'd be less apt to think that we're going to gain anything, especially if we try to move and lose our position right now.
Right,
You got it nailed right now, so let's just let go. Yeah. Yep.
we're
Nope.
doing so well
Thanks.
here.
You know, I think the way the dynamic of this, and I've got to read up on it a bit, but I think once you nucleate a site for hydrate formation, the very nature of this is that it's going to create these kinds of this kind of topography. And if you switched out 180 degrees, you'd end up collecting another mound on the other side, and it would be hard for it to even out. I don't think that's the way it would work.
Well, that's true. I mean, I don't think it would all collect, so it wouldn't just form a flat thing on the top, but it wouldn't all necessarily be on that kind of triangular looking thing like it is now if we did move it, but I don't think that we should. So the pilots were asking if we should nudge over to the left a little bit in order to get more of the bubbles coming up on the right side, since everything seems to be collecting on the left. But I think we all agreed that things are going so well that we don't want to mess with it.
Larry, Tom, we're 27 minutes into this now. It looks to me like we've got a hydrate structure that's probably hugging the left flank of the cylinder. We have no idea what the inner topography of that deposit is. It looks like it's about the lead edge of that's down at the 0.15 spot in the cylinder now, but it doesn't look like any hydrate is collecting to the right. So it's going to be difficult for us to play the 10% game exactly, but you guys are going to have to at some point let us know when you want to stop.
Okay, Jamie, we will do that. One of the things that's difficult to know when we're looking at this is, so if that bubble goes up and I think, well, for starters, I think time is probably going to be what really helps us. And as we look at that hydrate, one of the things we were just talking about is as that bubble goes up and adds to that stalactite or the hydrate formation, what we're wondering is if the gas on the outside of the bubble, which is in contact with water, forms the hydrate. But then once the gas on the inside of the bubble is no longer in contact with the water, I don't think it can form hydrate. So what portion of that is gas, what portion of that is hydrate? It's hard for us to tell, at least.
Well, I don't know enough about the chemistry of hydrate. I know it's methane molecules sitting in a water lattice. It's a kind of a loose ice. And I don't know how much of what we're seeing, that white deposit, is in the gas phase, really.
It'd be nice, Jamie, if we could zoom in to that white stuff at some point.
Yeah. I think the camera's at maximum up angle, so I think when we zoom, I'll see what I can do. But I think when you zoom a bit, you lose the top part of the cylinder.
Well, it might be we just wait till it gets a little lower down.
Yeah.
We can get that far. Careful.
Right. Yeah. I mean, you're pretty much where you zoom. You're zooming at the midpoint of the cylinder, which is
we're going to fill it that far.
right. That's the point. I think our ability to see it is compromised by the ability of the camera to pan up.
If what Tom is saying is true, we're getting just the rind over the gas bubble. Then when it sublimates, we won't get that real large change in volume because much of it is still really gas. Which will be a really interesting experiment. So.
Right.
So we'll find out.
We'll find out. Yeah, we'll find out.
Well, and perhaps it means that we might, given what we think is the structure and form of this ice, maybe you want to fill a little further than you thought.
Yeah. I think we'll just play it by ear and see.
Play it by eye.
Comfortable. By eye.
Play it by eye.
Jamie, there's one thing when this thing comes in. As we're saying, this kind of also helps the bubble size measurement and bubble flow rate measurement. If you guys can measure the distances between the 10% volume marks, also the diameter of the blue band on every fiduciary we can get in the diameter of the
diameter of the rope in the center of the cylinder. Is that what you mean?
And the blue band.
Oh, the blue band. Oh, yeah, sure. I mean, you can get dimensions for everything.
The width of the blue band.
Yeah, the width of the blue band.
Right. No worries.
That'd be great.
Yeah. No worries. We'll shoot you all those measurements.
Great. Thank you.
You have a very happy crowd at UNH here right now.
Well, good. Well, I think we're gratified that we've found the right diameter of seep. B, that there appears to be a higher rate of escape of bubbles than there were the other day. And C, that we're quite stable now with just the lip of the cylinder nudged against the seep with the ROV in the water. It seems to be stable. I think the conditions are really optimal. Water visibility today is really good too. So.
Yeah. Conditions and pilots. Yep.
Yeah. There's a little talent there too. I'm really starting to believe that the volume is not increasing all that much. That frame of what we see top is not that much greater than the bubble. As I watch a big bubble come up, it's kind of a catch on.
Agreed.
And I certainly don't see a 5 times expansion.
Oh no, I don't. But I think most of us would agree that this seep is expelling gas today at a rate that's higher than it was 2 days ago. Now, you can't back it up with a quantitative estimate, but it looks to me like the size of the bubbles and the rate of bubble escape are both more than, certainly the size of the bubbles appears bigger than 2 days ago.
I like that this is actually filling out as opposed to just going down. That's nice.
Yeah.
And to me, that implies it's more bubble-like as opposed to.
Yeah, when you see that bubble lodge in there, it
kind of just, there's one.
preserves its shape, right?
We've seen it perfect sitting on the band there, just being preserved its size, yeah.
And that might be different if we can go to the other end, or like Pascagoula Dome, like one, as the faster ones might look very different how that operates.
Yeah.
Maybe they'll compress more as they.
But this is the exact mechanism that we think keeps the gas preserved till it gets to the hydrate stability zone. Is that thin rind of hydrate over it.
Could be.
Yeah.
But certainly the growth that we're seeing here inside the cylinder mimics what we saw on that Vernon Asper video the other day on an admittedly much more narrow diameter tube. And that tube was not vertical. That tube was inclined, but nonetheless, it appeared as though the hydrate was favoring expansion along the contact with the material rather than in the center.
Yeah,
That's true.
yep.
Also, if you remember from that video, when he inverted that push core or whatever tube he had there, there was a lot of free gas came out.
That's right, yeah, there was a stream of gas coming out.
Well, and Macondo had the same problem, right? When they put that chamber over Macondo.
Great examples of these bubbles. Oh, there's one that was missed.
Yeah.
Okay, one that was missed. Let's put that down. That's the first one we've seen missed.
Yeah, we are seeing the odd bubble escape.
There's a second.
Now, see, what I'm a little worried about is that we may be forming hydrate also at the base near the flared edge. So what we don't know is whether we may be closing our cylinder at the base as well.
We might. I think actually we've shifted a little bit to the left because those bubbles that were previously behind the left-hand piece of yellow tape are now coming up in the center.
Middle, yeah, and we're missing two bubbles now that we missed on the right side.
Yeah, I guess what we're worried about is moving. It's possible that we've moved, although I couldn't swear to it. I'm a little worried about trying to get them to reposition.
No, I think that's.
Yeah.
If we can keep a track of it, we've got just two bubbles.
We're just looking at the position of the edge of the funnel relative to the carbonate hard ground below. If it's moved, it's been remarkably small.
Right.
Okay.
Yeah, no, I
I think you could well be right about hydrate forming on the underside of that funnel, and I think as we rise through the water column, we'll get a cue as to what the extent of that was.
Right. That bell at the bottom may be also creating a nucleation site for ice. And
is the Sirius camera zoomed in as far as possible? Because I might be seeing some brown stuff on the bottom, but.
We could, yeah.
Co-pilot, go for a max zoom.
We'll try a zoom there
on the collector there, if you can work it out.
Yeah, Bob Carney's comment is that the shadows on the rock in the background also give us a frame of reference for movement of the cylinder. If we've moved, it's remarkably small.
Yes, I agree. Well, look at this. I don't see anything in there, but there's a lot of it we can't see.
Yeah, if it's much, Larry, it might be on the inside of the flange where we're not seeing it. It's where bubbles are impacting the cylinder initially. There's got to be some kind of residence time of ice bubble contact with a surface before ice forms. It probably is not forming very fast, if at all, there.
We will want to keep this kind of zoom as we go up through the water column and see if we're losing gas outside of the funnel.
Right.
As we rise through the water column.
Yeah, this is the perfect picture as we rise up.
But two bubbles missed over whatever 40 minutes is. Whoop, there's.
No.
What is that? at a.
No, you're looking at both.
I'm looking at a bolt.
Yeah, I saw that.
We're now 37. We're now 37 minutes in, and it looks like you're.
Yeah, so 2 bubbles over 37 minutes is pretty good.
Please tell Bob Carney he should be writing his NRC report. You there, Bob? No answer.
That's funny. I think
you're seeing
just on where they're rising in
the reflection. You know, as the bubble comes around the corner there, it makes a perfect reflector, so you get a brightness
way
increase.
behind before they're coming up right now.
Yeah. So is it that the funnel is pushed up again?
That's on the internet.
Oh, fantastic.
So we're going to have to make a call here. We're not ready yet.
No, I would.
But that is what we've been talking about: is whether or not there isn't some ice buildup in the lower parts of the cylinder.
That's the X factor, isn't it? Because we should be including that in our volume calculation to know when to pull off, and if you can't see it.
Yeah, well, that's right. Volumetrically, I think it's probably small, but I think it's likely that on any surface continuously exposed to these bubble streams, we're going to get some ice formation.
Oh, it could well be.
Yeah, and we'll see that when we rise up. Look at it. Boom. It's like, what's that game? Pac-Man? Not Pac-Man. The little blob that fit into Tetris. I think that, because it seems like it's really discrete. Yeah. We haven't seen things that have kind of come up and see an individual bubble attaches to the rest of it. Not like something you can click on.
You know,
So it's nice.
Yeah.
Yeah. We're talking about the angle of repose of ice here, crystals.
Getting there, though.
Yeah. Oh.
Yeah, that's something, huh?
Those 3 big bubbles that just went bing, just remember the time code on that. Those 3 big bubbles that just went bing, just remember the time code on that. Video is on it.
Well, guys, I need to run.
Okay, Bill.
All right, I'll sign back on a little bit. I got to get my daughter somewhere.
Hey, Saturday's a wonderful thing when you're ashore.
Yes, that's right. Okay, bye-bye.
That's true. The world moves on, and those of us on Okeanos just live in this hammock of ease and tranquility. Other people have ice in their drinks, and we have ice in a cylinder. Yeah, that's it. You know, tranquility. We have landed. Hey, it's great.
One small step for somebody.
All right, there you go. That's it. You know, and you armchair scientists back in New Hampshire, you know, you telepresence guys, Larry Mayer, who never goes to sea, you know, just the way it is.
You should see the row of Barca lounges we have set up in front of the
Yeah, I can believe that.
here.
Yeah, flipping back and forth between, you know, some kind of NBA playoff game, and it's. But Larry,
You're watching us? How do you know this?
But Larry, when they talk to you about how fast does grass grow, you can say, I don't know, but boy, I know how fast hydrate grows.
Oh boy. I miss being out there, Jamie.
It's a beautiful day out here. Wish you guys were out here. There's plenty of room in this van. This is not the Nautilus. And you know what? I'm in a short-sleeved shirt. I am not freezing to death. It's fantastic. It's wonderful to have electronics that are not 30 years old, that need to be at 20 degrees Fahrenheit in order to work properly. But I can't have my coffee in here, so when I go off headset, it means I have to go back outside and have a cup of coffee before I come back in. Bob's going to get me for that. Bob's got so many things to get me for that he keeps a list.
Could you answer this question from Bob? How much accumulation can there be before little herd buoyancy is modified? I think we don't know, right? So a couple of questions here. Bob Carney asks, how much accumulation can there be before Little Herc buoyancy is modified? And that's a good question. We don't know the answer to that. I mean, they've tried to compensate for the extra weight of the frame on the front, and then also the anticipated weight of extra buoyancy from the methane. Although when it's in this hydrate form, it's kind of, I mean, we've seen these things kind of be solid and sitting on the seafloor, but I guess it would be more buoyant as we rise in the water column, yes, and turns into a gas. So the answer is that we've thought about this, or the engineers have thought about it, but we're not sure. And then another question from Bill Keeney. If the tube wasn't here, under normal conditions, would the bubbles turn into ice as they rise through the water column? And Jamie's shaking his head. He thinks not. Perhaps they just need a place to kind of nucleate
I think they need a surface with different temperature or texture to. We see hydrate forming along the lip of these hard grounds across which the bubbles pass. I think they need a nucleation site, and what we're seeing in the way the gas is actually accreting to the top of the cylinder in an uneven, stalactite kind of fashion that it's the nucleation, and it's an uneven process created by the local temperature pressure field where the bubble impacts the surface that creates how it accretes. Sure that there are those out there who know a lot more about it than I do,
Yeah,
but
we're going to have on the other hand here, Jamie, the fact that we see these bubbles rising to typically in the acoustics, rising to depths of 500 meters below the sea surface, imply that they are covered by hydrate coating, because
you think so? I mean, we've certainly seen evidence for oily sheen around the bubbles sometimes, and we've seen evidence for bubbles that actually don't escape the seafloor that appear to be covered with hydrate. But you think all of the bubbles, in fact, have a hydrate coating?
I think the ones that we see rising up there, and that's the whole idea of the experiment, how much of what we're seeing actually rises up, and I suspect acoustically we're seeing most of them rising. I suspect they all have this hydrate coating. There's been some work at Mabari.
Well, there you go. I mean, great. That's good to.
Peter Brew and others have actually followed up these bubbles with an ROV and captured them, and they saw the hydrate rise. And that's why at 500 meters or so, the hydrate reached the hydrate stability, into the hydrate stability zone. The hydrate brine dissolves, and melts, and then the methane goes into the solution.
And so, does the methane go into solution almost instantaneously? I mean, I know it's undersaturated, but it goes in right away?
Very thin layer.
Huh, great. Well, that's good. Anyway, we're hearing from our UNH colleagues that in fact, work by MBARI, the Monterey Bay Aquarium Research Institute in California, has done some tracking of bubbles from seeps like this up into the water column and have then sampled these bubbles. They do have hydrate surface rinds, and it's when these hydrate, you get out of the hydrate stability zone above 500 meters that you see these rinds disappear, and that the bubbles then, as methane gas, get reabsorbed into the water column, methane being undersaturated with respect to the ambient environment. So that's something I didn't know, and it may be in fact why these bubble streams are producing the acoustic anomalies that they're producing. That are one of the main reasons that we're actually here doing this experiment. Great. Telepresence is a wonderful thing.
Yeah, so if you just had bubbles that were just basically balls of gas rising through the water, would you not expect to see such an acoustic signal? Is it because they have a solid on the outside that you get such a strong signal from them?
Tom has to answer this one. Yeah.
The reason we see bubbles so well acoustically is that they look like little mechanical resonators. They look like a little mass on a spring.
Uh-huh.
So if you picture an acoustic wave going down, it's exciting the bubble basically. We have a pressure disturbance from the acoustic wave, And what happens is that the gas inside the bubble looks very compressible. It acts like a spring. And
Yep.
as that compresses, the water around the bubble moves with it. And so that creates a mass. So it's just like if you go outside, well, you can't do this on the Okeanos Explorer, but when you back to port, if you go push down on your car and let it go, it bounces up and down. It's mechanically resonating.
Okay.
So these, if we get the right frequency and the right size bubble, they look very bright acoustically, essentially, because of that mechanical resonance. So
Okay.
that's why we see them so well acoustically. The other part of that story is why do we see them so high up in the water column, and it's because those bubbles are basically being preserved in their gas in the gas form by the methane hydrate range. So that's why we assess that by looking at the morphology of the plume. Why should those bubbles be rising so high in the water column when the ocean is so undersaturated? And that's what Larry was just describing.
So Kelly, if there was no,
Aaron.
Was it Aaron? Oh, excuse me.
Yeah, Aaron.
If there was no hydrate coating on the bubble, we would see it acoustically coming out of the seat, but within a few minutes, so just within tens of meters of the seafloor, would go away because the
Right.
methane would go into solution.
Wait. Hey. You're muted.
So that was my question. You really wouldn't see these bubbles persist in the water column very long at all.
That's right. It's the persistence that's the key to indicate that they're covered. They should. I think again, going back to the Mabari papers, they calculated that it would take they were looking at about 2 liters. The bubbles that they were seeing would take several hours to rise to the 500-meter level, and that given the undersaturation of the ocean with respect to methane, it would have gone into solution in a matter of minutes. They'd never see it rise that far into the water column without the hydrate coating. Or an oil coating, too. An oil coating.
Yeah, there just needs to be something to impede, it's gas transferring across the boundary between the water and the bubble, and there has to be something to impede that in order to get the bubbles up high, and one thing that can impede that is the hydrate. Another thing that could impede that is if there's oil in the area and you have a coating of oil on the bubbles, that could impede the gas transfer as well. And when we see that, then we stop thinking so much about the methane hydrate stability depth, and we start to wonder if those bubbles can get up much higher in the water column before dissolving. And
well, perhaps they do. Perhaps that's what's creating these sheens at the surface.
Yeah, I think it's not unrelated.
Well, so when you get some oil slicks on the surface of,
Go ahead,
oh,
Mav.
you meant on the surface of the bubbles, right?
Right.
Well, when you get oil slicks on the surface,
but also on the
that's
surface of the
just,
water.
that could just be, bubbles of oil, right? Rising up.
Could be, but it could also be these oil-coated
Sure.
gas bubbles.
Yeah, I don't have a good sense for what the mix there is, but it could be oil droplets by themselves, or it could be oil on bubbles. It's hard to say. Probably.
It's a very important question.
Certainly, they see
Yeah,
a lot of
go ahead.
oil slicks in this area, on top of the Biloxi Dome, on top of other domes in the area.
Right. I too am keeping a stopwatch on this. I noted that. I appreciate it. Thank you. And I'm about to have a discussion with my colleagues here at UNH about the degree to which they want to continue. Tom, Larry, I am now seeing the lead edge of that hydrate down between the 0.2 and 0.3 divisions. Yeah, I'm sure you can see that. And now we're filling hydrate across the top of the cylinder to perhaps on the order of 5%. So the question is going to be, when do you think we've got enough?
I think we want to go a little more.
Okay.
By a little more, I'm thinking that on the order of another half an hour.
Oh, okay. Because we had originally talked about filling to on the order of 10%. I think if we go another 30 minutes, we'll be more than that, at least of hydrate in the cylinder. So that we're going to let you make that call.
I think the conclusion that we're coming to here, and we can't say if it's the right one, is that what we're not looking at is solid massive hydrate, that there is some free gas within that that white mass as well.
Right, I think so
So
too.
the volume expansion should be much less than we expect from solid ice.
Right.
So we're taking a chance, but I think that's.
So we have to. Well, we want to make sure that we have something measurable by the time we get up.
We're in the experiment mode here. You let us know. Give us a few minutes warning, so that we can prep the vehicles for rise. I've talked to Dave, and I don't think it's going to be possible as we ascend to keep the Sirius view of Little Herc consistently in the field of view the way you have it right now. I don't think that's realistic. So what we are going to be stuck with is the view forward from the Little Herc camera of the cylinder that you have in the Little Herc view now. That's going to be it.
That's a great view, though. I think that'll get us most of what we need.
It is, and right with this zoom, I think this will allow us to judge what's going on. So we have this zoom on Little Herc, which will allow us to look at stuff escaping around the base, and then on the quad feed, we're still looking at the top. And so I think between those two, I think we're in pretty good shape as we ascend.
Okay, that just I've checked out the view from Sirius, and that will go away largely when we leave the seafloor.
Okay.
So when you get that really solid hydrate, is that just you have something like this, but then with pressure over time, it gets compressed, do you think? Anybody out there? Tom?
Well, I'm not sure that you don't have to go from gas to hydrate, right?
Hey, Tom. Larry, this is Dave. Can you hear me?
Yes, we can.
A couple thoughts here. One thought is that, judging by what I'm seeing right here, I think that to help you better get a handle on the amount of material that's coming into the tube, I think we're going to be able to provide you with enough information with the way the video is being done in the frame count, that you'll be actually able to pick your favorite students and have them sit and actually count the bubbles that went into this tube with a fair amount of accuracy, I think.
Absolutely,
Yeah.
It's phenomenal.
Yeah, that's a great view, and I think we'll actually be able to get a good estimate not only of the number but also of their size
And rise rate.
and the rise rate. Yeah.
Yeah, I think you've got. I think that although the calibrations are helpful, I don't think that's going to be your biggest friend in this process. I think that you've picked a really good area and a good flow rate that I think it's going to be very manageable to actually count the bubbles and also get sizes and everything else. I mean, I think this is going to be good.
Yeah. I wouldn't anticipate returning to this site with a calibrated grid. I don't think it's necessary.
Yeah. The other thing is there was a suggestion made that there might be some value in turning on the EK60s to see if we're capturing a lot of bubbles that are not coming up in the water column any longer that would be detected by the EK60. Do you have any desire to experiment with that?
That is a great suggestion, and particularly if we can do that now and then see the change as we move off in the next 20 minutes or something, that would be wonderful. That's a great suggestion.
Okay, we'll jump on it and let you know when we get there. Okay.
Yeah, the EK60, that's a.
You should see nothing. But, might be able to see what.
Okay. How can an acoustician not think of that?
Well, no, we can test it.
Go ahead. I have an hour and 8 minutes as well. Yep, I started it exactly when you did. I believe Webb was headed out to do that. And
yes, let's stand by. Webb is going to handle that.
And if that's true, we probably want to put the EK60 out on one of the quad views. So there it is. Tom, Larry, we're getting up the EK60 now, and we'll get it out to you on one of the quad views.
Okay, that's great. You guys are you're wonderful. One thing to keep in mind with the EK60 is that is still a big footprint.
Right, sure.
We may be picking up another seep as well, but it's still very interesting to look at.
Well, we only saw one other seep in this area, at least doing the non-search waypoint to waypoint pattern we did on this site the other day. So, but your point is well taken.
It's true, but yeah, with the EM302, we had a couple other guys in this area too. But yeah, well, let's just see what there is to see. Yeah, it'll be fascinating. Particularly that before and after, as we move off
Right.
and let those bubbles start to come up. I mean, it actually will take bubbles a while to rise up into the water column too, until we start seeing them up off the bottom. That'll tell us something right there.
1, 2.
Yeah.
How's that? Is that better? Sorry.
You have a known volume, and then we're releasing it?
Roland, did you have a question for me?
The interesting thing is how, so we're releasing a known volume of gas, and then it will fragment into smaller bubbles because it's very unsteady, and the the surface tension will pull that gas apart into smaller bubbles. But the fragmentation rate is something that we would be assessing almost directly there, which would be very cool.
It'll be at 300 meters or so. So a much narrower tube.
Yeah.
Like this.
That's true, actually. Would be. Yeah, Jamie, I don't know if you heard that, but we were just talking about the possibility of releasing that gas from the methane bucket. So after we come up to our 300 meters or whatever depth we're coming up to, if we release that underneath the EK60, we're going to see a very interesting evolution of that big mass of gas as it fragments into smaller bubbles.
Yeah, well, we certainly anticipate once this hydrate exsolves into gas, releasing it presumably by lifting the top of the cylinder. So I have no problem leaving the EK60. It doesn't seem to be presenting interference issues for our equipment, so I have no problem keeping the EK60 on and getting it. I guess we need it in terms of positioning. Do you want it right under the boat?
Under the EK60, yeah.
Right, yeah, so we'll just keep that in mind as we come up and get the vehicles positioned where you want them, and then we'll do it.
Cool.
You're actually going to see the ice. The ice now contains most of the bubbles. It actually hydrate or frozen gas or clathrate or frozen gas hydrate is actually a loose lattice of water ice and methane ice. And so the gas has actually now become mostly an ice. And one of the questions we have is, how does this gas reacquire its gaseous characteristics as we move above the stability zone for this ice? Right now, this ice is stable at 1,400 meters, or approximately where we are, 1,370. And as we move up slowly, this gas will, or this ice will slowly change back into gas. And the idea is to try to get a sense based on that of what the volume of gas was that we actually collected. So, and we'll comment more about it as we rise. We're going to rise slowly on the order of 10 meters a minute, and watch changes in what's contained in the cylinder as we move up to shallow depth. And why 300 or 400 meters? That appears to be where they stop being able to see these acoustic plumes on the EK60. Somewhere in the above 500 meters, based on work that's been done, these bubbles persist as plumes because they're coated in this ice, and it's not until the ice disappears as surrounding the bubbles that the gas can be redissolved into the seawater, because the gas is undersaturated in seawater. That's yep. Well, they've certainly got a fair bit of hydrate in there now. I mean, that's if I had to guess, and I had to even out the meniscus on that, I'd say that they've got on the order of at least 15% of, maybe not, maybe it's not a lot more than 10, but I'll bet you it's more than 10.
Jamie, I think we still like our hour and a half. I think that hour and a half probably is up in 10 or 12 minutes.
Okay. I'll give them the heads up. If that works for you, we'll start preparing for that.
Okay, that sounds good. Thank you.
Nav and pilots, I think we are going to be ready to begin our ascent phase at 1 hour 30 minutes.
Yeah, Nav, this is Dave. I'll go down and make sure that everybody knows that we're going to do a crew change before we do that. Before we start the ascent. Okay. So yeah, stand by.
Bill Keeney's asking about the relative methane saturation of the water within the tube relative to outside the tube. I certainly would envision, Bill, that the methane saturation inside the tube is higher. But as to your question about how might this affect how the hydrate forms and how it will dissolve, I couldn't answer that. And Larry, if you want to, or Tom, if you want to weigh in there, I don't know the answer to that.
Yeah, I'm not sure as far as the hydrate formation. I do think we have a question about how, as it returns to gas, how it dissolves. And I think our hope is that that happens very slowly, so that by the time we get up, we get to our measurement depth, that we're measuring essentially the same volume or very close to it, that we actually captured at depth.
Yeah. Given how slowly this is formed near the seep, it's hard for me to believe if we're rising at 10 meters a minute, which is, on the order of an hour and a half or so, that we're going to see things disintegrate instantaneously. But we'll see. I mean, that's why we're here.
Yeah, I think we're thinking it'll be a slow process, and that's just what we want.
yeah. I mean, why is it? Why are you even asking the question? Uh, yeah, you know, I mean, it's when when you ask silly questions like, "Is there something you don't want?" It's just it's like asking kids in candy stores. Feel free to bypass the first counter. And my experience with scientists is the more gadgets there are around, the more they want. Yeah, that's fine. Roger that. A gang switch. Roger. Yeah, that's great. Thank you. Gentlemen, we're going to want to leave this site as gently as possible. There's always the possibility we'll come back for another go here. So let's be gentle as we go. Gentlemen, I've got you at an hour 30 now. The call is made.
So if you guys can remember to stop your stopwatch, that would be great. You know what the
As soon as we leave, I will.
Thank you, Jamie.
Tom, Larry, you guys hear me?
Yeah, we can hear you.
Okay, so I just want to make sure we're all on the same page here. We're going to pick up. We're not going to change the camera angle or the zoom on Little Hercules at all. We're going to go into a normal mode of ascent. We're not going to linger here at the site. Is that correct?
Yeah, I think we should, just as you described, I think that's what we should do, yes.
Okay, and then we'll start our ascent, and we'll arrange for
Big gas bubble there.
an ascent rate that we feel is safe to keep things as stable as possible so we can not affect the experiment. So if you're in agreement with all of that, we'll proceed.
Yeah, I think that sounds good to us. Yep, we're nodding our heads here. Sounds great, Dave.
Okay, thank you. Okay, Dave.
At your leisure, gentlemen.
Yep, we're ready anytime you are to come off this site very carefully and then go into a towed ascent mode. Dave, I don't have any sense of how stable or unstable this stuff is, so when you turn, obviously go slow and see what kind of movement we see there. Okay, thanks.
Larry and Tom, for the record, we collected gas for an hour and 33 minutes.
Temperature is 4.36, Jamie.
Yeah, I think we've noted that
Okay.
a number of times, but it's good to do it again.
You're now up. Temperature, that's, yeah, we can keep track of that. We do have that command unit feed
So when you want to play the temperature, create a video temperature.
I think that's the video. That was just a blurb on the feed.
No smoking.
Right. Right. No smoking on Little Herc right now.
Roger that. We copy that.
Dislodge some bubbles that were mostly trapped.
I personally.
Yeah.
Very gently.
Roger. Thank you.
It's swelled from 15% now at 1,400 meters, and we go up to 300 meters. It's going to change by 14. Divided by 3. Right. So quite a bit. I mean, that would be perfect, actually, for us. That'll get it right down to here. And that would make a very nice zoom right in on that. That would be great. So I'm hoping it works out just about. Yeah. Okay. Aaron just said there was bubbles trapped in the cone.
Yeah, that's what the pilot had said.
Okay. It went into the cylinder or out of the cylinder?
1 second.
It went into the cylinder. It went up.
Ah, okay. Yeah, he said that it went into the cylinder. It went up.
Great.
Good. Just so
Wait, whoa. Wait, sorry, what was the question?
Serious lights.
Oh, okay.
Shut down the serious lights and all that.
Yeah, okay. Okay, yeah. Yeah, just so everybody's clear, we made we made sure that we weren't going to touch anybody's lights on Little Herc for the rest of the experiment. So just so you know, no experiments.
So stop coming up for.
I thought I'd seen a few more.
It all switched out toward each other. Make sure all is happening. Setting below.
Yeah.
Crystalline light. Yeah.
Should be growing, right? I'm sorry, I should be growing. It should be going up. Where's that? Where'd that come from?
Well, yeah. I don't know how fast they're going up, but there could be a random bubble. You know, that's naturally definite. That might be running faster. There's a bubble that.
Hey, Dave, what's your ascent rate right now, you think?
It's about 2 meters a minute. I'm just getting stretched out here to get a good look at the tethers and then creep up a little bit as we go.
Roger that. Thanks.
The main snow cone. So it's still very close to the bottom. Yeah, yeah. Very close. Yeah, yeah, 10 meters. Okay, so that's kind of normal bubble size. Sort of a natural bubble. Yeah, that's true.
Creep up to 10 a minute and see where we get. I don't know, about
10 meters a minute is 16 centimeters a second. That is, I think the terminal velocity is about a kilometer or something like 20 centimeters a second. So about on the order of. You could have bubbles, natural bubbles kind of streaming by. That might be why they kind of come in and out. Not like a bubble. Yeah. Easy to get confused by the.
Nav, this is Dave. Yes, could you do a quick calculation on our ascent time to 300 meters and also to 200 meters at 10 meters a minute?
Okay.
Thank you.
This right there.
See this top one here? Line rate, -10, time to surface value, 120.
Okay. But I want to go to, yeah, I want to go to 200 meters and 300 meters. So that requires more thinking.
Another thing is keep an eye on the thruster effort.
But yeah, thank you.
Go to colors.
Oh, Cheerios.
What's that?
I was promised there would be no math.
It'll be approximately
Will hurt. They were able to go to 25.
100 meters depth and approximately 110 minutes to 200 meters depth.
Said 100 minutes to 300 meters depth. And what was the other one?
And the other one is 110 minutes, 110.
Okay, 110 minutes to 200 meters depth. Is that right?
That is correct. Delta 14, if that got me too much up in the light, I can slow down a little. Oh, you know what? Stay the light on. Don't worry too much.
Right now we're at 1,300 meters depth, altitude of now 45.8 meters from this. Oh wait, sorry, or 22.4 meters. That's the altimeter jumping around. So Bob, you asked it, so if primarily gas, the volume should double by 700 meters. Do you mean if this hydrate is primarily made of gas? And Tom says unless the hydrate brine prevents it.
saying at 10 meters a minute was the target ascent rate. Yeah, all right, well, everything's wonderful right now.
So that's an interesting point. We have two things happening as we rise upright. We have the gas expanding and then also the hydrate surrounding the gas dissolving. So what if the gas expands before the hydrate dissolves? I guess the bubbles just pop then in that case. Bill Keeney wants to know, is the tube sealed now at the bottom or still open?
It's open at the bottom.
It's open.
Yeah, the bottom of the tube is open, and the top of the tube has got the spring-loaded valve, which is closed. And we now have 4.42 degrees centigrade.
For those for those of you watching the event log, it may be worth joining the real-time data chat, as that's providing an update as to vehicle depth and temperature at each vehicle every second.
Go ahead, Jeff.
If I plug these remaining two HMIs, we might actually get a decent image of Little Herc in the mini zooms here.
I'm sorry, say again, Jeff.
If I plug in the remaining two HMI lights, we might get a pretty decent image of Little Herc in the mini zooms.
We'll lose our tether cam in Little Herc if he does that.
There's a light off the back of Sirius around our sugar light up here.
Oh, excuse me, Jeff. Thank you.
Yeah, Jeff, I don't have any strong feeling either way. As long as we're not doing anything that's going to jeopardize the experiment after we've worked this hard is just fine.
I don't see any risk there at this point. Something we haven't tried before, and it seems like a safe thing to do. We certainly can turn them back on if we don't like how things go.
So we just turned off the HMI on the Sirius's camera to see if we can get a better view of Little Herc. And you can see it.
Yeah, they're probably yeah. Yeah, they're zoomed in. It's pretty impressive. Good visibility.
Okay, that's pretty good. I mean, it makes it look like the hydrates are very in. It's still more zoom to get so far in that so accentuates the motion. delta. Yeah, we might do it this way. The only reason we kept the H&Rs out is in case one of the bias blows out of the depths into the HD.
I gotta get some lunch. What's that? No. Well, you're just back. That's fine. I got 15 minutes. We started ascent. Already got the first couple of. We're just doing 5-minute. The only thing I think you need to go back and look at. I had some notes for Sirius. I was just starting to go look at this.
It's annoying.
And then that's about it. I mean, I don't know. I was out of the room for a while, so I don't know after this time code if there was other stuff that I'm going to scan through that. And then right now, I've got sled 2 in there. One, so you can see the vehicles. I had it in there for a little bit on the feed too.
Yeah, pressure recovery at 600.
Fuck you.
Now with the clathrate formation, it's taking up some of the gas, so phase changes on demand. So
Webb is just pointing out to me that you can see the vehicles leaving the bottom on the EK60, so I believe that's on your quad view, if you all see that.
Yeah, we can see that. It's very cool.
Looking at the linearity of that line, I think it's pretty safe to assume you are looking at a constant ascent rate.
I'm looking at the red record button on the EK60. Are you guys recording?
Good question.
I mean, on the EK60, not in the video.
Yeah. One moment.
So who is that on the phone asking about the EK60?
Tom.
So Tom, we are not recording the EK60. So, but we can start, and we can definitely. What we can do is once we get a little bit more data on there, we can actually record some video of the EK60, which would show the essentially the end effect. Showing the entire ascent as well as the USBL interference. Would you like us to do that?
That'd be great, and it's not too late to start recording. As we move off those bubbles and they start to rise up the water column, they'll take a long time to rise up, those bubbles are probably rising about as fast as little Hurricane Sirius are. So yeah, if you could start recording now on the EK60, we'll get some great information out of it.
Okay, sure thing.
Yeah, go ahead.
Yeah, what's the plan when the phase change starts? Do we just maintain a constant ascent, or will we adjust our ascent rate based on developments?
Yeah, I'll double check on it, but to my knowledge, there's been no talk of changing the ascent rate. We may come to a stop at some point in time, but I'm not so sure we're going to make any stops along the way until we get to a certain point. But good question. Let me hold on for a second. Let me see what we got. Tom, Larry, you hear me okay?
Yeah, Dave.
Yeah, there's been a good question posed by the guys up front, and that is when we start seeing some changes in the hydrate, is there any thought as to whether you want to slow down or stop? Do you want to change anything, or do you want to just continue to come up at what looks to be about a 10 meter per minute rate?
I think we just continue. Yeah.
I think that we're thinking just keep continuing at steadiest rate.
Okay.
I think that is what we'd like.
Okay, will do. Thank you.
It's hard to know exactly how everything will go, this being the first time, but we stay the course right now. I think that sounds good to us.
Okay. If there are any changes, just let us know. We'll react as promptly as we can.
Okay, will do.
So, Dave, it appears that for now there is no plan to adjust ascent rate or stop if we see any changes taking place. So unless they come back and ask us to make a change, we'll just assume that we're going to continue just the way you're going. Great, thanks.
Okay, Tom, this is Webb. EK60 is recording.
a few of the bubbles near the bottom of that of the formation. So they were pilots were noting that some of the bubbles near the bottom of the formation moved a little bit, so they just kind of wiggled around.
They just kind of shifted and moved up the formation.
Okay.
Slightly.
Okay. Right.
It looked like they just shifted.
Yeah. Yeah. Shifted and just moved farther up, basically.
It'll be really interesting to play this video back at high speed and watch how this changes. It'll be very cool.
Right.
Is the ship moving?
So Aaron, I don't know how this, I mean, this kind of experiment may be taxing for sort of the high definition recording. You know, we're interested in, you know, while we were sitting there filling over an hour and a half, we're interested in the high def video for that, for bubble sizing and ascent rate and that kind of thing. And we're interested in it as we're rising through the water column to watch how that hydrate formation changes. And do you guys have limitations there? I'm guessing you do.
Yeah.
But I don't know what they are.
Sure. This is WebPinner. We do have limitations on our video capture system, and what we're attempting with this experiment is definitely a departure from the exploration nature of the way the video system was set up around an exploration nature, a much more opportunistic clipping. We're not really configured for this duty cycle. Luckily, it's early enough in the cruise that we do have the capacity to take all this in. But had it been later in the cruise, or if we do this multiple times, we will run into a space issue. But for this particular experiment, we should be able to capture it in its entirety.
Oh, that's wonderful. Great, thanks.
Yeah, it's in terms of file size, raw file size, you're probably a couple terabytes per hour. So we're going into 3 hours. I'll get you an exact calculation once we finish all the clipping.
Okay, and so that is
You should
because
have done shopping before you left for the cruise.
Well, we have a 130 terabyte storage array on the vessel.
Oh, right, okay.
So yeah, but only half of that is usable because we have 2 chassis, so that when we record it, the recording goes to both chassis simultaneously, so we can actually lose a chassis without losing any data.
Yep.
And so that capacity is cut in half, as well as there's some other partitioning that happened to allow, just as part of the processing workflow. Usable is about 50 terabytes.
so what we're using right now is higher resolution than what we're normally using when we're just running around on the seafloor.
No, this is the same resolution, but just give you this is actually worth explaining. So the feed that you see on shore on the Internet 2 feed, that is a 5 megabit feed. So every 8 seconds is 5 megabytes. The ship natively records 145 megabit to 150 megabit, depending on how hard it is to compress the incoming video. The more motion, the harder it is to compress. So you're looking at almost a 30 times. There's 30 times more information in the full resolution video that we capture on the ship versus what the Internet 2 community is seeing.
Got it.
So, but we do that for several reasons. First of all, as you notice, the frame captures, there is a great bit of quality in those, and you cannot get that without capturing the video at the highest resolution possible. So that's one of the reasons we do it. We also record it in a format referred to as ProRes 422, and this is a broadcast industry standard. It's the same format that would be used. Movies actually use it for that's their native format. television, and the like. So we try to record to broadcast standards. The system that we use actually is straight out of the broadcast world. It's a system made by a company called EVS. It is an instant replay system, just like you would see used during the Super Bowl or the Olympics, or any event that would require fast instant replays. That was a functionality we actually utilized yesterday that allowed us to very quickly show you what video had just been captured so that we could confirm or deny the presence of bubbles. But it is not configured like some other platforms optimized for an always recording type of workflow. Todd Gregory. As was Joe Biscotti. From Parts Unknown.
So Tom had observed on the event log that the hydrate formation appears to be extended a bit further down. I remember, so I don't remember how it was when we first started our ascent. Was it still halfway between 2 and 3?
Bob Carney was just making the observation that the point at the bottom of the formation was in line with the panel behind the cylinder when we started off from the seafloor.
Okay. Might just be my imagination, but those things at the bottom do kind of look more, I don't know, less tightly packed together.
Little Hercules passing through 1,000 meters.
So we're just passing through 1,000 meters, and at this current rate, it'll take us about 30 minutes. Sorry, 70 minutes to 300 meters.
Tom, this is Webb Penner from the Okeanos Explorer. Something we could do, if you're curious, is we potentially could show you where we started in terms of volume filled. We could put that up on feed 3, and you could actually compare where we started on the sea floor to where we are right now.
That'd be interesting to look at.
Okay, what we're going to do is we're just going to, we use this channel to do the clips, and we need to keep clipping, but just so you can see, for a few moments, and we can flash back to this periodically. This would be taking away from our clipping, so we can't just leave it up, but just to give you a quick show.
Oh, that'd be great. Thanks, Webb.
Okay. Okay, Tom, so you should be seeing on feed 3 where we started.
Yeah, that's really nice to see. Definitely a difference. I'm actually going to grab a screen grip. There we go. So now we can have it up in perpetuity on our local screen here. Yeah, go ahead, Kevin, that's fine. Yeah, I think Bob Carney's observation was exactly right. It's extended down below, and then I think he and also the pilots had noticed that other piece sort of more towards the center of the cylinder had moved over to the right. Apart from that, sort of bubbly nature down below 2 centimeter, or the line number 2 there looks similar, and it looks somewhat similar up above, although expanded there too, I guess. Actually hasn't. Well, that's super. Thank you, guys.
All right, roger that. We're going to switch back now so we can continue the clipping process. So Tom, that kind of demonstrates some of the functionality that this system was designed around. That's an example of how the instant replay allows us to very quickly go back and show you previously recorded video that was recorded during a single dive.
Yeah, that's really nice, and we made good use of that yesterday too. The instant replays of the bubble formations near, as it was coming out of the seabed was really great to see too. We were trying to decide what it was we were looking at.
Right. Yeah, my team actually came in. I was working in my stateroom. They actually explained that they were doing that, which I thought was great because, that's a perfect example of what this system was designed to support.
It really helps for those real-time adaptive decisions. And just a general understanding of what it is that we're seeing. So Larry, you missed it. They had a screen grab. They had what it looked like on the bottom as we looked, so we could compare. And I actually took a screen grab, so it's right here, so you can see the change.
It's also looking like a change in the the actual character. Those look pearly, and those look much more eroded.
Yeah, that's what Aaron was remarking on earlier.
Right, yeah, I see that too. Just a little while ago, I saw one come out of the right side, and then just now from the left side.
Yeah, you can see them actually forming on the left edge there.
Right.
Yeah,
That's not what I wanted.
The question that I would have is that whether it's coming out from the collection cylinder, or whether we had collected some on the valve before we actually closed it, and it's starting to change characteristics and come off.
Yeah, that's a real fair question, Dave. I don't think we have a way of knowing the answer to that.
Right. Yep. So,
Oh, sorry. I misunderstood what you were doing. No, I think we're good for right now. Sorry. Hold it. I want to ask first.
Yeah.
So, Tom, I don't know if you can see this in the pilot cam that's in the quad display. It's the lower right-hand quad. We have seen bubbles escaping. We don't know if they're coming from inside the cylinder or if it was just something that was stuck to the outside during the collection process. But we did just see bubbles actually in that camera that appeared to be ascending just slightly faster than we were. And I have here on the ship, we've actually changed the recorders so that we can actually record that camera. As you can see, actually right now, you actually see some bubbles rising in the pilot cam.
Yeah, thank you. This is Kevin and Larry right now. We're seeing that as well.
Okay, so what we're gonna do is when there's a major event there, if there's a major event there, we'll be sure to grab it.
Okay, thanks a lot.
Yep.
That's huge. Oh, good, yeah.
Where did that come from?
It's a good question.
Did it come from the back side, like the part that we can't see behind it?
There's another way. That's how it looks to me. It's coming from the top half of around the back. This is movement inside the bubble cluster as well. So inside the cylinder.
The
Things are expected to happen at 300 meters. It's like the vacuum vortex is inside. Heard that Bambi the bomb?
yeah, this is Dave. I've heard a couple different numbers. I've heard in the 400 meter range as well. So I don't know that anybody really entirely knows. I think that's one of the things that we're hoping to see.
We're about 2 degrees warmer than we were on the bottom. About a degree and a half warmer than we were on the bottom. Celsius. Yeah, centigrade.
Yeah, so we're at about 5.6 degrees temperature now. 5.6 degrees Celsius.
I don't. So we just seen several bubbles.
Oh, no kidding.
So that they started recording. So it could be coincidence.
Yeah.
Could be valve come off somewhere.
right? Did you see all those bubbles escape there? Oh, we're grabbing that on the video.
Looks like that one was caught in the netty there.
Are those bubbles coming from the flange?
Possibly. We're looking at it right now.
You mean the flange instead of the valve?
I don't know.
There might be hydrate on some of the structure that we never captured in the first.
Right, that's what we don't know, if it's from a hydrate that formed there before we even closed it, or
Usually it sticks underneath
if we don't have a good seal.
It's stuck under the strip that's going out. It's right on the edge of the frame. That bubble was just moving around and it just stuck right there. That's interesting.
I like being able to crawl
Maybe it froze there. Maybe there's a...
Oh, that might have been stuck under the rail.
In the tube, yeah.
So our depth is 830 meters right now.
Want to be able to see each one of the K60 individual bubbles.
Okay.
I'm right out here in the driveway. I'm just watching this.
Going to make just a hitting shit to the left? Yeah. Yeah. Put it on the big screen here. So, okay.
Hey, Jeff. Yeah, the term "uh-oh" really scares me. Thank you.
seem to be bubbles rising fairly regularly from the bottom of the chamber up into the top.
Bubbles rising routinely from the base of that thing.
Right, yeah, I would say maybe one every 8 seconds or so. And Bob Carney,
Hydrate deposit that we don't see behind the flannel, which is exsolving and giving gas up to the top of the cylinder. So there's a hydrate formed at the base somewhere out of sight. And because the same thing's happening to the hydrate at the top, but the bubbles are, the gas is up, ponded up in the meniscus above where we can't see it.
some of the discussion on the event log is about bubbles that are rising up from the bottom, possibly resizing faster because maybe they don't have a skin over them, like the ones that are pooled at the top.
They're more in full contact with seawater that is more undersaturated with respect to methane rather than the cylinder stuff, which is probably at a higher concentration of methane per unit volume.
The temperature of the water actually down by the base could actually be much warmer than what's present.
It's interesting to observe them rise
Right,
inside that
that's a
tube
good
because
point.
that water isn't moving with respect to the bubbles.
And Webb just made the point that the water at the base could be a lot warmer than what's up in the tube because it's getting more exposed to the surrounding water, which is warmer.
It's mixing with the air from the
Right.
just call it top end of the tube.
Let's see here. We are about 2 degrees warmer, 2 degrees centigrade warmer here than we were at the base.
So, based on what we're seeing from that simple crossbar in terms of its bubble raise, it's easy to imagine that the valve mechanism had hydrates on it before it was sealed. And those hydrates are now experiencing 50% of the pressure.
Do you want to capture every 5 minutes of the top end since it started leaking, or just some frame graphs?
Well, I'm trying to argue that we might not. It's plausible that we don't.
Are you talking to me? Who are you talking to?
Talking to Webb. He's thinking.
But I don't know how to prove that.
I can hear the wheels.
I want to say no.
So Bob was observing that we're passing external bubbles. So, for example, there on the right or the left side of the screen, I think those are bubbles that are rising up at about the same rate as we are, but we're overtaking them slowly. And so Tom is wondering if we're capturing any.
Well, it could be. I mean, you can see them vibrating slowly as they move up through the water column.
So those ones that are inside, though, that are rising up to the top, they're going, they must be going pretty fast since they're not kind of holding still relative to us, or is that they don't have any drag, kind of?
That water is rising with us.
Yeah, oh, that's true.
But there are
The whole mass of water inside is rising with us, too.
And there are a lot of eddies around the framework and everything. That's why you see bubbles come out and they shoot
Yeah.
sideways instead of up.
Right.
They're caught in the turbulence of the water around our framework.
I started putting the first time I put the screen on. Sorry, I put it all the way that far back. And you're keeping up with the big one, so now you're just gauging it. We still have lots of room on each of them. We still got the window over yesterday. Well then, alright, then go ahead. Yeah, we must have deleted it wrong because we got 4 hours left on the train.
And so Tom just said that they would be expecting the bubbles to rise at a speed of about 15 to 20 centimeters per second or so, which would be a little bit faster than Little Herc's ascent rate. But then, as I think it was Jeff was also pointing out, is that some of those bubbles probably get caught in turbulence eddies that are occurring around the sub as we rise up. So it's a lot of fluid dynamics going on here that can affect their ascent rate and trajectory as well.
Larry, Tom, it's Jamie. Do you want to? We've been rising on the order of 10 meters a minute, I guess. You want to stop at a particular point, or what's your feeling here?
I think what we're thinking here is that if we don't see anything happening by the time we get to substantial happening by the time we get to 300 meters, we should stop at 300 meters.
Okay.
But apart from that, I think we should keep going.
Roger that. No, that's fine. You know, I've been staring at the image of this ice really close up out in the dry lab, and you know, it looks like a worm's nest. It's a whole series of little tubules lightly connected together, and I can convince myself that it's actually starting to erode from within. It looks like the layer is more transparent than it was, the layer on the left, than it was when we left the seafloor. So I think you are seeing some erosion of the ice, but it may be that the gas is ponding up near the top out of sight, and we just haven't seen it yet.
Some of it's escaping through the valve.
It could be that we're seeing some of that, as Larry just pointed out. We could be seeing some of that escaping out through the valve. You know, I guess it ought to be expanding too, right? With Boyle's law.
Yeah, I would think it would be. Yeah, and temperature hasn't changed a lot. It started at 4.36. Now it's at 6.7. It's not a huge difference, but certainly temperature and pressure's been a lot different.
We're seeing a pretty steady streak of bubbles coming up.
Yeah.
Just a little bit, you know,
There's another. I think basically the top is leaking. Count the bubbles here. Ones are recording. Yeah. There's another. Take a look at it. I think that's what's happening. I think we're seeing the melting of the ice, the pushing back the gas.
Maybe we're seeing the formation back. Yeah. I mean, back melting of the ice.
These are bubbles that are disappearing. See? Think they're going into solution?
No.
Yeah, the lead edge of that ice is definitely eroding now. Slowly, but it's eroding.
Going up on 3 degrees warmer than the bottom.
Yeah, less than half the pressure. So, I mean, and it could all of a sudden start to accelerate when it reaches some critical temperature threshold. You could see it start to.
Yeah, so your boiling temperature is rapidly dropping and temperature is rapidly rising.
Right.
John, do you have the ability to show temperature on that CPU screen? For a series? Oh, never mind.
So you think the gas is leaking out of the top?
So much of it there.
Greg brought up an interesting point. He didn't know if the cable stretched.
It could have. That spring's got a lot more tension than I think it needs, but maybe we'll look at that today. One of the agrees that the escape open valve is accelerated in the past 100 meters. Could have been some hydrate formed actually on the valve itself, so that when we tried to close it, there was
I think it's about to get interesting.
Yeah, I think we're going to see a big change relatively fast. I don't know exactly, but it's going to be somewhere above 500 meters because that's where they begin to lose these plumes.
we just passed through 600 meters.
Yeah, and gentlemen, the perspective of our CCOM colleagues is that if we get to 300, we want to stay there for a while. Not if what we do, but when we do, want to stay there for a while. But where's all that gas coming from the base? That's what I want. That's what I'm trying to figure out. Is that's got to be exsolving hydrate that formed around the base of the flange, where the flange joins the frame.
I wonder if those are the little copepods that are always crawling around on the scanning of mats.
Took a ride. Going to be one unfortunate copepod when he gets to the surface.
Jamie, that is something we'd be able to study because before we close the valve at the top, we could, once we park over our seat, we could have the camera pointed right at that crossbar at the base.
Yeah, it's true.
Zoom in really tight.
Spend a little time and see what's growing where.
Yeah, because you're right. I mean, it's surprising that we still have lots of clumps of bubbles coming out.
I just can't for the life of me figure out where that could be coming from unless it's hydrate that's starting to destabilize at the base somewhere. They're out of sight.
Yeah, the funnel and there's a piece like this that could get trapped.
Jamie, when we were collecting the gas down at the seabed, we didn't see as many bubbles coming up on the right side, and so maybe we're seeing what is just what you say, that hydrate formation on the underside of the funnel now dislodging. Or,
yeah, I think there's a plug down there out of sight
or whatever it is
that we're seeing now. What we're seeing is what is also happening at the top, but the bubbles at the top are out of sight because there's a meniscus at the top that is gathering gas.
Are most of those bubbles rising from the bottom coming from the left side?
Some from the right side as well. I mean, the question though, I mean, given that fact, you know, your census of bubbles is going to be low because all you could do was measure the bubbles that are going through the tube. Some of those bubbles, you're going to have to compare the bubble rates before we got on top of the cylinder with the rates that we actually saw in the cylinder to see how much of the gas we didn't get that was forming hydrate out of sight at the base of the cylinder.
Yeah, that's right. Which makes that video we collected,
before pretty
really
important.
valuable to us. Yeah, that's right.
Yeah, you can see it. It's really, as we get above close to 500 meters now, things are starting to speed up. There's definitely erosion of that left side lead edge of hydrate on the upper part as well. We could see a catastrophic collapse of this ice plug at the top too. It could just all of a sudden just disaggregate because it's a real worm tube aggregation of ice anyway.
So there's still lots of bubbles coming out of the top. Do you think it's feasible that if that much ice was forming below, down in that funnel, that as much had formed at the top?
Who's to
or
say?
do you think that that's coming
Who's
from
to say?
inside?
I mean, you've got
now?
a lot of area. You've got more area inside that flange than you do at the top of the cylinder.
Well, certainly, and also I don't know at what point that ice would have formed other than when we were messing around before we actually started collection.
I think when it counters a surface, you start out with a sheen of hydrate, and that hydrate is receptive to being aggregated.
Now those bubbles are coming out really fast at the top, which makes me think that they're coming from inside.
I think bubbles that rise up from the bottom pass through the.
We also need to get the attention.
You think they're leaving? You think they're leaving the cylinder, huh?
Yeah,
I think so.
The bottom is
Now.
warmer and dissolution is happening much faster at the bottom and it's passing right through and out the top.
But I thought the top was closed. Have I got that wrong?
The top is closed, but obviously it has a leak.
You think so? You think we're not just perhaps restabilizing some hydrate in the plug in the middle up top?
We haven't seen any bubbles come out of the center of the plug. They always come out from the periphery.
Yeah, I guess I'm not convinced we have a leak in the top yet. Of course, we can't see it, but.
There does, Jamie, does seem to be a good.
Well, if it's not a leak, it should stop at some point, right? While we still have gas in the cylinder.
You call it, Tom. You let us know what you'd like to do.
Oh no, we're happy to keep going. I was listening to your debate about whether those bubbles are coming from in the cylinder or.
I think they're coming from inside the cylinder. The question is, are they exiting the top of the cylinder? My own feeling is that we're seeing exsolution of hydrate at the base, but those bubbles are inside the cylinder, and I think they're pooling at the top. Nobody's convinced me yet that the gas is leaving the cylinder.
Well, that's what Tom was asking. He's asking if the bubbles at the top are coming from inside the cylinder.
I believe they are. That's my opinion, yeah.
The bubbles leaving the top, you think, are coming from inside?
Leaving the top. Where are they leaving
this is
the top?
the top right over here in
okay.
the pilot cam view.
I've been watching the wrong view. Well, yeah, maybe so.
See how there's a steady stream.
Yes, then I agree that some gas is leaving the top.
It's a pretty steady stream here.
Right.
Those pesky engineers just haven't given you a gas-tight seal at the top.
Now, are we seeing stuff in the water column? I can't tell. It's actually see both holes, right? That we'll see.
We do see. I mean, what used to be green is now a little bit yellow.
That's fine. I think so. I think if we're debating this, we want to make sure that everybody's got a full view of what we're talking about. I agree. Oh, I guess I didn't realize I was looking at the top of the cylinder there.
All right, just so everybody's aware, watching the feed, we've switched feed 2 from the Sirius HD cam, which was pretty much black given the lighting, to the pilot cam, so you guys can see that off gassing from the top of the apparatus better.
You can see it coming.
Oh yeah, that's much more clear.
And so that, but that's showing us that it's exuding, that's all. We just want to.
Good call, Brian.
We'll have to do it backwards.
Yeah, absolutely. That's, there's no question that what is leaking from the base of the cylinder is rising within the cylinder and then leaving through the cap. So, I'm not sure about that. I mean, we'd know if we started to see gas ponding inside the cylinder below the base of the hydrate at the top, but
Because the other thing that could be happening is bubbles are coming up, there might be mixing the internal water volume, essentially warming the water inside, as well as heat transfers between the bubbles.
no way of knowing without doing samples. There's no way of knowing where the gas is coming from. The gas that we collected from the seep has got a pretty distinctive chemical signature, but without having been able to sample it.
Well, I mean, the question is, I think that we're debating about is whether the gas leaving the top is just from the bubbles coming from the bottom and rising up through and coming out the top. I think that's probably happening, but is there additionally some, for lack of a better term, melting or exsolving of the stuff that was already trapped inside at the top on that formation?
I would think at this depth and temperature that would indeed be happening, Aaron. But either way, this is any gas that's leaving the top, even if it came from the funnel, is gas that was part of our capture. And so this represents a loss to our volume measurements, regardless of whether it is coming from the top of the cylinder or from the bottom.
Yeah, right.
Fire them all, I say.
Pretty fascinating to watch this evolve, though.
Yeah, unfortunately, you can't really get a good sense of exactly how many bubbles are leaving the top and how big they are because they kind of come out and float away. Directly away
Aaron,
from
I
us.
thought you were counting them.
I just mean, even if you saw this video again in slow motion, I don't think that you could see all of the bubbles and know their size.
That is why God invented graduate students.
Yeah, good thing I'm not one of those anymore.
That's right. That's right. Well, there's no question. There's no question that that's a relatively porous top, and the question is whether or not the plug was poorly designed or whether we're just not able to tug it down hard enough against that spring tension to seal it the way it needs to be sealed. It just, we closed it, but we didn't close it tightly enough. I mean, I don't know.
There was some discussion going on earlier about that and how they tugged it and then they tugged it even further and felt that extra bit was just stretching the cable basically.
But you're tugging against an O-ring seal, right? Is a single O-ring?
Well, I don't know. Yes, single O-ring. So the strength of the cable is about 1,000 pounds, a couple thousand pounds.
Well, the answer is I can't answer that.
Yeah, good Good observation. So the pilot has said that the mass, the bottom of the mass has started to kind of climb back up above where it was before. So earlier it expanded so that the bottom was down. And now perhaps because it's dissolving and some of those bubbles from the bottom are leaving there and moving up towards the top, it's kind of the bottom tip has climbed back up again.
I think we're probably underestimating to great degree the degree to which hydrate formed behind that flange. I think there's a big plug of hydrate there. I think what we might see pretty soon are pieces of that ice. If it collapses catastrophically at the base, we may see pieces of ice start to rise into the cylinder along with the bubbles. I think there was a lot of hydrate down there. As I understand it, it's cages of water ice around the gas. So as the water ice disintegrates, the gas is released. I don't think it's a catastrophic process, except if a lot of the cages get thin at the same time and fragments just start to break apart.
Well,
that's what we saw the other day in that video, Vern Esper's video. Saw a lot of fragments of stuff start to move.
But how buoyant is methane? Is there a very large force just of, that methane pushing up on it?
Well, I think it would. I think if it broke apart, if there's a plug at the base and it broke apart, I think you'd see it in the cylinder. Is that what you're asking?
No, I'm asking the force that the methane is pushing up on that seal, on the cap at the top.
Oh, it's open at the base. I don't think there's a lot of force there.
Well, of course, I mean, it's trapped inside, so. Oh, right, I see, because you're displacing the, all right. That's the idea.
It's just a badly designed, no, I'm just. It's interesting. I wouldn't have thought, given an O-ring seal and the degree to which it could be pulled shut, it surprises me we're losing as much as we are. We think it is, but that camera, what was the force exerted by that camera?
I don't think we could put a number on it, but when we first put it together, everybody thought there was a hell of a lot of tension.
Right.
It'll be interesting to see what we have
when you get back. Well, but the idea now would be not to release the cap when we come back up, but to leave it the way it was and see if there's a gap in the closure.
I think if we just close it while everything's still cold and wet, we'll get a pretty good idea.
Yeah.
Things have changed a lot.
I would think you could just, I don't know, seal one end and put some compressed air in there and just get a feeling if you can hear gas escaping around the O-ring. Well, we're now at 450. Temperature is rising, but not a lot. It's at 9.62 degrees now. Twice.
Did you take note of that time where the stream was running steady now? 1833.
Oh, guess we stole your.
Yeah, and that could be small cages, water cages, that have started to break apart with residual gas in them, starting to.
A pilot had observed that there is some flock visible inside the cylinder.
Yeah.
Where? I don't see it.
The white stripe at about the 7 mark, if you kind of look at it in that region, I think it's just so much reflectivity from that band.
You see 1, 2, 3, 4, 5, 6, 7. There's a white mark across the back of the.
Uh-huh.
That's what he's talking about.
So it looks like critters.
Oh, I see now.
Seeing some stuff floating inside.
Yes. Now that I can see it closer up. I don't have my glasses to see that monitor far away.
And there's look how fast that upper plug is decaying now.
Yeah.
Look how fast it's decaying. It's decaying very rapidly now. You can see the spring. All of a sudden, it started to go fast.
The rate of bubbles coming from the funnel has.
Look at that. It's going away. It's going away very, very rapidly now, that plug of ice.
We're at a depth of 426 meters. Temperature at the ROV is 10 degrees centigrade.
Did you?
Vehicle is at a depth of 424 meters. Temperature is 10.5 degrees
That plug's
centigrade.
going to be gone very quickly now.
I can see bubbles in my monitor starting to dissolve from the mass, from the ice mass. Yeah, it's very prevalent. Accelerating.
And you're seeing some flock around the edges of that, and that might be coming from residual material near the base of the cylinder. But that upper plug started to go very, very rapidly. Well, I think that plug might be gone now.
400 meters wire out.
Roger that, pilots. 400 meters wire out.
Okay. There was some up there.
Now, what caused that movement of the camera? I'm sorry, I missed that.
That was me, and the discussion was whether it was not head creeped, was not fully up.
So up would have meant tighter pull on the top. Ah.
So you increased the tension. It doesn't seem to have done anything about the bubbles, but I'll pay attention to that in the future.
Right.
Gentlemen, we still want to stop at 300.
Roger, stop at 300. Will do.
So the pilots were discussing whether the camera would have crept down because of the tension on that wire, and that just to pay attention to it in the future. And so he did move the camera back up, but it doesn't seem to have really made a difference as far as the bubbles being released from the top.
Design we should do on a call after.
Yeah, no, just what we're thinking is for subsequent dives, we might just want to seal it. Not worry about having a close it. That we seal it and take our chance with getting over the seats with it closed.
So you think that maybe it is because something formed on the seal while we had it open?
Yeah, we'll talk about this after.
Okay.
I don't think it's going to take very long for this ice plug to disappear visually at this depth now. We're losing it very fast.
What's that
now.
in the cylinder?
Yeah, we're. Yeah, yeah.
The big float up in the bottom.
And it looks biological, actually.
Right. I don't know what that was, though.
Whether that was a chunk of hydrate floating up, or if that was something.
You know, it's something you're going to have to zoom in and look at again.
Right. Look.
Some more.
But a very fragile hydrate.
Yeah, it's not gas because it's not rising that quickly. That's stuff coming up off the pump thing.
But it could be little pieces of ice that are residual pieces of the plug. That you know, that's the way it might look. I think little residual pieces of ice kind of floating up with bubbles. It's clearly still something down at the base because you're still seeing bubbles coming up.
Yeah, look, you can watch it.
Amazing how much hydrate must have been in that funnel.
Yeah, I think you're right. I think, you know, it argues for a clear piece of plastic there rather than a dark piece. We want to have visibility as much as possible.
Good thinking, Jamie. That's a good idea.
If you want, I can swing by Ace Hardware tonight.
Yeah, that's another option, is to actually to remove the funnel.
I think we would have missed a lot of what was coming up without the funnel.
Could be. I mean, I don't know if we have an option of putting some kind of a gas collector at the bottom that's clear. Yep. You can see discrete little pieces of it starting to float away.
Vehicle is at approximately 370 meters. Temperature is 11.5 degrees centigrade.
You can almost watch the edge of that ice recede now. Look at it turn into bubbles.
Interesting.
Yeah, I see some.
Yeah, I see it.
So this should, if they're right, this should go gaseous.
Did you see any of this in Sirio sonar, or is it just too far away?
It's capped. It's capped. Yeah, it's capped, and you've got a saturation curve which is different than open water. Getting close to the top of where we see plumes in the water column.
Might be too far away. Yeah. Well, we're pretty stretched out here, so I don't know what you're going to see it on Sirius. That's her. Different ways of looking at bubbles. That's it.
Haven't seen a bubble come up from the base in a while. That plug may be gone. That plug's going to be gone here shortly. It's almost gone now. Can we get a zoom now on the top of the cylinder?
No, we.
That's it. That's it. Oh, of course, because when you can't center up on it, can we?
No.
Fair enough.
We also, if we're having a continuous record,
Right. No, it's.
once we take a frame grab, we'll be able to zoom in.
Right. I guess we can only blow it up in a image later, right? Yeah.
Just about gone, folks. Just as we start to slow down for 300 meters. Just about gone.
Cool. Yeah.
Oh yeah, you can see. Well, you can see it exsolving in the cylinder now. You can see the bubbles coming from the cylinder.
Yeah.
Actually stop at 285. It's just a big movement of what's left of the mass up at the top of the tube.
Yep. Well, it's dislodged from its nucleating points now. It's probably just floating under the cap. You mean once there's no gas for it to leak, would there be gas leaking? Yeah. Tom and Larry, I don't think you're going to have to stop at 300 very long. I think it's going to be gone here momentarily.
Yeah, but we should open it up anyway, just to practice the opening and see what happens. There's probably some bubbles that are stuck under the cap.
Okay.
I can still see a little bit left.
All right, approaching 300 meters. Co-Valet, 300 meters. Roger that.
We'll open it up just.
Sirius is stopped with 285 meters of water out, or wire out. Little Herc will hover about 300. I think whatever ice was there is gone.
It also seems like whatever gas was there is gone, unless you can. I can't really tell. I
There
suppose.
may be a little under the cap, but you let us know what you want to do now, gentlemen.
Yeah, they should go.
Yeah, you guys can open it if you want.
Why don't we? I'm not sure who's responsible for opening the top lid, but why don't we do that?
Just as an observation, though, there's still something that looks like some kind of material at the very top above the top coil of the spring.
I can't see it.
A little better on my monitor.
Okay.
But it doesn't seem to contain a lot of gas bubbles. It's kind of hard to push that button.
There you go.
Okay. Tom, Larry, Dave's feeling is we don't gain much by opening it now. He'd just soon leave it closed. He wants to assess the degree to which it was closed when we get it to the surface.
Okay. That's sensible.
Understood.
All right, they understand that. Okay. So, well, it is our pleasure to recover.
I think that is our pleasure.
I think they're okay to recover.
Fantastic. Absolutely fantastic.
All right.
Okay, Jamie, we're gonna do some tether management and
Roger that.
get into formation, but we will begin recovery.
Roger that.
Yeah, you got the most exciting
Jeff, I
part.
gotta back up. Twist out. And I gotta come south. Let's take you a twist out. Just to hang there for now.
Well, I think Dave's right. Dave wants to take a look. You know, he could open it up now, then he can't understand why it's leaking. But if we leave it closed, just for, pure pleasure about watching.
Congratulations, guys.
Yeah, no, that was great.
Yeah, this is Okeanos Explorer. We're in the midst of dive 3. We have just ascended to a depth of approximately 300 meters. We've been watching the erosion of a hydrate plug, really two plugs, one in the top and one at the base of the cylinder mounted in front of Little Herc. We've watched the erosion of that plug or plugs as we have ascended from a depth of about 1360 meters to 300 meters. We've decided to leave the top of the cylinder closed, although the hydrate appears to be now completely gone. We have decided to conclude the dive. We're getting stable and we're going to be recovering now. It's too late. It's almost 2 o'clock local time to do anything more today. We will be having a follow-up call at 2:30. You want to do it now? Okay. I guess we're going to change that and have the call now to do a discussion of what we would like to do tomorrow on Dive 04. And so stay tuned. We're going to talk a little bit about it. Larry and Tom, if you're there, stay on the line, and we'll have a follow-up call right now.
We're here. We'll be ready.
Wait one while we're getting Dave and company here.
Just want to let everybody know on OKEX that this is Okeanos Video, that they'll be doing the conference call from our lounge. So you'll need to call into the conference call line to participate in that. Thank you.
Tom and Larry, this is the EX Watch Leader. Are you still there? UNH, this is no ship Okeanos Explorer. Are you there?